Okay, today's video is going to be something that I looked for and had a hard time getting information on, so we're going to try to fill that in. You should see the title, and it's going to be how to create multiple ribbons out of one ribbon emitter. This seems like something that should just work, that's intuitive, but actually it requires a bit of finagling. Maybe in later engine versions, there's a way to do this without scratch pads, but I honestly don't think so. I did look. This is in Unreal Engine 4.26, and we are going to, it applies for something like this. So let me isolate this one. So you notice that even though this is just one emitter, there's multiple ribbons. And that is quite important when you're trying to make something like this. That's like a circle or something like that. And we are going to do that today. Let me turn that off. The one we're actually going to make is going to be a bit simpler. It's just going to be this. So see, it's one beam or one emitter, but it's multiple ribbons that have different values associated with them. In this case, it's just color and movement, and we're doing that just to show that yes, it is indeed working, but you can apply it to whatever unique values you want. Like in this one, they're all at a different angle and such. Okay, I'm just going to move this over for reference, and let's create a particle. It will be a Niagara particle. We're doing new system from selected emitter. We're not going to use the dynamic beam. We're going to use the static beam. It'll probably work for the dynamic beam as well, though. But if you want to follow along one for one, we are using the static beam. So if we, I always feel like there's never enough space in this particle setup. Okay. So here's the our beam. This is just the default static beam. I'm going to change a few things. I'm going to delete the color. I'm just going to mess with the width a little bit just so it's like different. And then I'm going to, just so it doesn't disappear, I'm going to change this 3 seconds to also the emitter length right here, so it's always present. And let's check the timeline. So that way we can always see it. So it shouldn't disappear anymore. Okay, excellent. The first thing that, just to kind of describe how beams work and why we even need to do this in a roundabout way in the first place, is there's something kind of counterintuitive about beams and how they render. So notice this is using a spawn burst instantaneous, and it's got burst count 100. So that means there's 100 beams, right? Actually not. With beams, each particle basically acts as a vertice on the model. You can kind of see this. It's a bit hard to see because of the contrast. Maybe something like that will let you see it. Let me turn off the grid, actually. There we go. So notice when I adjust this, so I'm going to lower it. Notice there's a lot less vertices. And then if I increase it, it becomes a lot denser. Obviously, if the beam is, straight, you don't really need a lot of vertices. But if your beam is bending a lot and you want it to be smooth, you would want to add more. So that's what the vertex count actually does, which makes it tricky. Well, it's like, well, what if I want multiple beams, like something, like this, and I want each beam to have a different value, and I don't want to have to just like duplicate dozens and dozens of emitters. That would be a complete hassle and would be very hard to do and inconvenient to make any changes or small adjustments, because then you'd have to change every single beam. Well, you can, the thing it's going to involve is this variable here, the ribbon ID. And we basically need to create our own ribbon ID. The ribbon ID is basically the count of the vertices and how they're linked to the ribbon. I'm sure there's a better technical explanation, but this will make sense in terms of how we can use it to our advantage. The first thing we're actually going to do is just more of a convenience thing. We are going to make an int, which in particles will be an int32. And we are just going to call this ribbon amount. And let's give it a value. I'm just going to have 4 ribbons for now. And this is going to be used in a few different places. So that's why I'm making a user parameter, so it can be kind of adjusted in one place. And it also makes math a bit easier for us. So for example, if we're doing this, we always want the particle count divisible by however many beams we want. So an easy way to do that is multiply by int, and we'll slot our beam amount in, and then we'll slot how many vertices we want per beam. Our beams are straight, so don't really need a ton of vertices, so we'll only have 6 vertices per beam. I don't think it's quite 6, but yeah, I don't think it's 1-to-1, but a lower number will be less vertices. That's basically what you need to know there. Okay, so that's all set up. That's divisible by however many beams we have. By the way, make sure this is set to something in your default. If your beam's not showing up, that's probably why. And now we need to do something called set parameter. Set parameter, and we are going to basically create a custom. So scroll down to where it says particle attributes, and there's this ribbon ID. We want to make a custom ribbon ID that will be, it's a special type of parameter. The parameter name is actually a Niagara ID. That's the type of parameter. It's not a float, it's not an int, it's a Niagara ID. Technically the int, there's the int baked into it. It's kind of like a struct, but it's this compound ID. And we'll call this just split ribbon ID, just like that. You can tell it's ours because there's not this like lock next to it, so it's editable. And this is the thing we need to set. We want to set this parameter basically before everything else within the particle spawn. And we're going to do the drop down, and there's a button that says new scratch dynamic input, and we will click that. Let me pull up my reference. And this is where we'll name this one create split ribbon ID, just like that. I'm going to give her some space since we're going to be working in the scratch pad. This is actually going to be fairly simple, but there's some critical elements to it. So we'll remove this pin, and we're going to add a pin. We're going to have 2 pins. Both pins will be ints, so this will be an int 32. And then the next one is int 32. And we will rename these. I'm going to call these input underscore, and the reason I'm doing this is because this is not actually the variable. In some cases you can drag a variable in here directly, but we just want to have a slot for it basically. So this one will be input underscore execution index. And then the next one will be input underscore ribbon amount. That's the variable we created. But again, this isn't actually that variable. We're going to reference it. And all that we're going to do in here is we're going to do a math function called modulo, which basically just outputs the remainder. And we are just going to output that as the ribbon ID. Notice this won't actually... Or I guess it will. Will it? No. Okay, yeah, it's not going to connect there, but that's to be expected. We need to create, since this is an int, and we need to, I think we need a, not ribbon ID, ID. Make Niagara ID. So this will go in the index. The tag, you can literally just leave 0. That's no big deal. And then this will actually plug in like that. So this is our scratch pad. We are asking for the execution index and the ribbon amount, and we will apply this and go back to our system. So look here. This is our dynamic scratch pad. So it's got an execution index. And if you search return execution index, this is actually a kind of like a function. It's almost a scratch pad itself. So if you just look for the execution index, you will get this execution count. That is not what you want. Don't get fooled by that. You want the return execution index function, basically. And then we can grab our ribbon amount, which goes in here. Okay, so we are splitting this ribbon ID. And the next critical part is we are going to take this split ribbon ID and we are going to slot it into this ribbon ID. So instead of using the default ribbon ID, we want to use our split ribbon ID under the ribbon render. That's a pretty critical element. Otherwise, I don't think it will work correctly. Let me just, as a sanity check. Yes, you'll get this weird kind of thing, which is a cool effect to be said. If you just set the ribbon ID without putting it into the ribbon ID, into changing the render settings here under the bindings. But by changing the bindings, that's how you get it to be distinct. Like that. This is the thing that I had trouble finding information about, is that I needed to slot it in here. I think I don't even know how I figured out how to do that, actually. Okay, so now technically it's set up, but like we're not doing anything. Like the whole point of this is so we can do special things to the different ribbons. I think they're all just like stacked on each other right now, which is no fun. Notice, by the way, they do spawn at a slight offset. You probably could offset them manually, but the easier way to, like, if you just want it kind of a hack, you can just increase the vertex count, and that'll also decrease that. So like 32. Okay, so now that we have them set differently, let's do something with it. We want to make an array. So select the linear color from array. We're going to add 4 in here. So I like red, green, maybe blue. Let's set the alpha to 1 for all these. And what should this, maybe orange, yellowish. Okay. And then for direct set, we want to create a new scratch pad. So for the array index, new scratch dynamic, and basically we want to get an int from the ribbon ID. So we can call this ID to int 32, like that. And this is going to be a dead simple one. So we will add a source, so the ribbon, not the ribbon ID. Technically you could put it there, but I want this scratch pad to be adaptable. So I'm going to grab the Niagara ID. We're going to rename this to input ribbon ID, just like that. And then we will break Niagara ID, and we'll just grab that. This one we don't need. So this is all we're doing here, is we are just grabbing the the int from the ribbon ID. So now that we have that, notice what's happening here. Where did my particle go? I don't have my grid. Okay. Okay, so this is broken since we actually need to set the ribbon ID. So this ribbon ID will go here. So technically this would be, let's rename this. This would be the split ribbon ID. Technically it would work for any ribbon ID, but the split ribbon ID is the one we're using. And now that we have that, see, they're all different colors. And okay, so that was a bit of a hassle, but the nice thing is once you have that set up, once you can grab an int from the ID, you now have a unique ID for each ribbon, and you can basically just copy this. So let's say I wanted to add some velocity, and I want to multiply this by a float, and I want this to be an array. And we'll do 4 here. Instead of random, we want direct set. And then we can jump to this, and we can literally just copy this ID to int 32. And then we can jump back to the velocity, and we can paste that in here since it's an int as well. And then what we can do is I'm going to make this one, this -1 on z, and this will be 1 on y, and this will be -1 on y. And then I also have a float here I can multiply it by. So there we go. We now have multiple ribbons from a single ribbon. So in summary, the way this system works is you need to create a custom Niagara ID, name it something like split ribbon ID, and then you need to set it, and then you can use a modulo to divide up the existing ribbon ID by the amount of ribbons you want to create this new ribbon ID. And then from there, you need to put that into the ribbon ID binding. And then you can also use that and grab the int from that ID to do whatever unique thing you want to do to each of your ribbons, whether it be changing the color, right, or changing the movement. It's whatever you want to do uniquely to each ribbon, you can do with this. I'm now going to overview this electric effect a little bit. I'm not going to recreate it or anything, but I think it's cool enough to just kind of show off, like, okay, once you have this, kind of give some examples of what you can do with a split ribbon ID. So with this one, see, I don't actually have a lot of vertices since this is using an electric material, so that's where most of the detail comes from. It's not actually in the vertice. The ribbon, where is the add float? I have a scratch pad here. Circle from ribbon. This is kind of a cool scratch pad. It took some math. But this basically takes the radius, the ribbon link order, which is the split ribbon ID actually. Or no, this is straight up the ribbon link order. And basically doing some cosine. This is trigonometry, cosine and sine, and we are just calculating like the radius, and then we can blend between it being a circle and it not being a circle, and we can also blend how much of a circle we want it to be. So notice initially it kind of goes around, and then it's made to kind of replicate this initial